So looking at this front page of your notes, this is the last section of chapter 7. Usually what they do in the last sections is they kind of start to throw everything together. Okay, a lot of the time, this is when we're starting to deal with overlapping triangles. Okay, which is exactly what we're looking at today, but I want you to understand that you have done all of this before. We're just looking at, instead of probably 2 triangles at once, they're just throwing a bunch in they're throwing a bunch more in like this. Okay, so looking at this picture, how many similar triangles do you see? How many, where'd you get that? It is 4, you're correct. You just counted them, right?
Yeah.
So here's 1, 2, 3, 4. How do we know they are similar to each other? Okay, the parallel symbols that we are actually learning about that today. Why else are all of those similar? The congruent markings on the sides, and they share, all of them have that angle. Do you agree? All of them come from that angle. Okay, and both of these sides are their shared sides. So we know they are proportional to each other in a way. Cool. Without those values, we can assume that. So there are 4 similar triangles here. So usually what we're used to seeing is problems with just 2 triangles. Okay, today we're just adding on extra stuff, but everything you know from here on out still applies. Okay, so go ahead and flip to example 1. Okay, we're going to work through this example together. This one's not in your notes, however. So on this one, it tells me that LN is 9.6. You did a lot of problems with this yesterday. How can I find LM? What's a proportion that I can set up? If I start with X, what does X relate to?
9.6.
Okay, I agree with 9.6 and 3. I'm going to do 2 different things here. So I agree with 9.6 and I agree with 3. Because some of us are setting them up and they're asking me if it's correct. It is. You're just doing it the other way that it can be done. Okay, so here, this is the big triangle. This is the, small triangle, big triangle. Here, what do you notice about both of these? They're all in the same triangle. So this whole proportion here is triangle 1. Okay, so coming back up here, since I started with X on this one, what do I start with on the other side? 3. What does 3 relate to? Careful.
8.
Yep, we want this whole side, so it's 8. Okay, I'm going to come down here. I started with X, and I related it to 3. What relates to X on the big triangle? 9.6 over 8. And here's triangle 2. I want you to understand that setting up proportions it can go side to side or it can go up and down. Okay, so here we had triangle 1 on the top, triangle 2 on the bottom. Here we had triangle 1 as its own fraction, triangle 2 as the other fraction. Okay, both ways you set this up, you are going to get the same answer. Okay, so let's do that. If I do 8 times X, 8X, 9.6 times 3, help me out. 28.8. Someone clarify? Yeah? And then I divide by 8, I get X equals, I believe, 3.6. Okay? Now, just double check this one. I get 8X equals 28.8. So do you agree I'm going to get the same answer? Mm-hmm. Yep. So understand, if you're setting it up this way, that's cool. If you're setting it up this way, that's cool. Okay? So what we just found is LM is 3.6. How could I find MN? I could subtract them. Could I also set up new proportions? Yep, but what's probably easier is just take 9.6 minus 3.6, which is 6. So this side length over here is 6. The other part I want to talk about here that's new is we're not used to these parallel symbols. Okay, so a theorem I'm going to have you write down towards the end today. Those parallel symbols, so this step 4 that they have here, if the ratios of the sides are proportional to each other or equal, then we can for sure say they're parallel. So what I mean by that, let me erase some scribbles here. Okay. I'm going to compare the 2 sides. So I'm going to compare this side and this side. The reason for that is because, do you agree those are the lines that the parallel lines are touching? Okay, so let's set up, what's a ratio I can set up for, I'm just going to call this side A. What's a ratio I can set up for that? I can compare 3 over 5. Since we have a decimal over here, let's type that in our calculator and get a decimal. What's 3 divided by 5? Should get 0.6. Okay, so let's check side B here. What's a ratio I can set up that is similar to this one? Side B here. Yep.
3.6.
Yep, 3.6 over 6. Could I have done 6 over 3.6? Nope, same thing. You want to keep them proportional. What do you get when you divide those? 0.6. So this tells us that, yes, these are parallel to each other for sure. Cool. Okay. Looking at your example 1 here in your notes, it says BD bisects sides AC and CE. What does bisect mean? Bisect means splits it in half. So they're talking about this line BD. It splits these two sides in half. Is that true by the labels they gave us? Yep, because on the left side, both of them are 5. On the right side, both of them are 6. Okay, so it's asking if BD, so our line here, and AF, they're asking if they're parallel to each other. How do we figure that out if they're parallel to each other? What did we just talk about?
Dividing.
The side proportions, right? We got to see if they relate to each other by their ratios. So what's a ratio I can set up for the left side?
5 over 5.
5 over 5, which is 1.
6 over 6.
And then the other side is 6 over 6, which is 1. So what does that tell us? That they are parallel. Yep, these are equal, so that means that they are parallel. I want to talk about real fast. So here we talked about that GH bisects these two sides to get congruent sides. We talked about how they are parallel, right, by setting up the ratios. Okay. The other thing is that if these sides are congruent or it's bisected, we can also assume this. Okay, so what that equation right there is saying, and I'll have you write this down at the end. Don't worry about it right now. It says that GH is half of DF. So let me just put a quick example with this right now. If DF is 60, what's GH?
30.
Because you did what?
Divided.
You took half of it. You divided by 2. If I give you another example, if this side is 7, what's this length? You doubled it. Yep. If we went backwards, it would have been 3.5, right? But if we're getting bigger, remember it's getting doubled. Okay? All right, last example for today. This one is in your notes. So this is kind of like what I was talking about at the beginning. We are used to seeing problems with just 2 triangles. Okay, well, what do we have here? We have 3. Okay, so we got to think a little bit more on what's happening here. So the first thing, I know it's not outlined in your notes this way, but we need to find what x is first. Okay, we want to find what these 2 values are to help us find those 2. Okay, so there's just going to be a lot of proportions being set up here. So I usually have you start with x. So x, what does that relate to? So if I'm looking at this side here, what does x relate to? X is this part. So the rest of it is 12. So x over 12 equals, well, since I started with x, what do I have to start with on this side? X plus 2 over, what's the rest of it? 16. Ignore this down here. Yep. So we're going to cross multiply. So x times 16, 16x. What are we going to have to do here? Yep. So 12 times x is 12x. 2 times 12 is 24. And then solve, subtract 12. So we get 4x equals 24. Divide by 4x equals 6. Okay. I want to use this information now. What can I do with that? What does that tell me? Plug it in, right? So this side is 6. What's this side? 8. Yep. So what does your part A say? What's it want you to find?
Y.
Yep, it wants us to find y. So when you're dealing with a bunch of triangles, you want to limit to what two triangles you're looking at. Okay, so y, do you agree, is in this triangle? Okay, and then we want to compare that to the whole shebang. Okay, so if I'm setting up a new proportion, what can I relate y to?
30.
Correct. Yep, y can relate to 30 because of where they're positioned. What is another ratio that I can put together?
Is it?
So usually we look for other values.
Oh, is it 12 and 12?
I can put 12 over, so he picked this side, which is fine. You could also pick 9, but let's stick with this side. What's the whole length of that side for the big triangle?
Oh.
24. Yep. So cross multiply, 24 times y, 24y, 12 times 30, 30, 60. Last step, divide by 24, y equals 15. So there's your part A. Let me erase scribbles. Part B, what's to find what? Yep, now we want to find z. Do you think it's going to be pretty similar to how we found y?
Yeah.
Okay, are we looking at the same triangles? No. Z is a part of this one, right? Okay, and we're comparing it to the whole thing. You're more than likely always going to be comparing it to the whole thing. Okay, so what's a ratio I can set up for z? What's z relate to?
Z over 30.
Z relates to 30, again, because of where they're positioned. What's the ratio I can set it up with?
Is it
So again, here's my triangle Z.
16 over 24?
Where'd you get the 16 from?
Added 14 or 4 and 12.
Yep. Could I also do this side? Yes. I want to just show you. Let's do this side. Okay, again, it doesn't matter what side you do. So 9 plus 3, 12 over, where do I get the rest?
Add all together.
I add this whole side together. So I get
18.
18. So I get Z times 18, 18Z, 30 times 12,
360.
360, last thing,
Divided by 18. It's 20.
divide by 18, I don't know why that's cutting off, that's okay. Divide by 18, Z equals